Hi, and thank you again for looking at one of my videos. Today we are kind of entering the world of computers because we're going to have a look at how the binary number system works. So the binary number system is in some ways simpler than the system that we use to count in our normal lives. So usually we have the digits 0 to 9. So when we are writing down numbers, we have columns. The first column is the units, the second column is the tens, and then the hundreds, and so on. So if I write a number 359, 359, it means we have 9 units, 5 lots of 10, and 3 lots of 100. Now, in this system, as we go from right to left, each column is therefore worth 10 times more than the previous one. So a 5 in this column is only worth 5, but a 5 in this column is 5 tens. It's 50. Similarly, from the tens to hundreds, that is also multiplied by 10. So 5 in this column is 500, and that's what its value. So in the original number that we wrote down, the 3 is 3 hundreds, 5 tens, and 9 units. Now let's compare this with the binary system. Now, the binary system kind of works in the same way in that we are going to have columns of numbers, but in the binary system we only have 2 digits. We have the 0 and the 1. 2, 3, 4, 5 does not exist. So if we are looking at the columns, the first column is the ones column, but there is only a 1. So the next column, instead of being 10 times bigger, is only 2 times bigger. So this column is the 2's column, not the 10's. The next column is times 2, and the next column is times 2, and so on. So 2 times 2 means the third column is the 4's, the fourth column is the 8's. So instead of having units, tens, hundreds, thousands, we have 1's, 2's, 4's, 8's, and it would be 16's and 32's. What does this mean as far as writing a number? Well, if I write the number 1, that is it. It is simply the number 1. However, if I want to write the number 2, then if I put a 1 in that column, in the 2's column, that is the number 2 with nothing on the end, just a 2. If I write down a 2 and a 1, 1 in this column, 1 in this column, a 2 and a 1 is 3. If I then want to go to 4, I would put a 1 in this column, 1, 4, no 2's, no 1's. That would be the equivalent in binary of 4. So for instance, if I write down 1, 1, 0, that would be 1, 4, 1, 2, that's 6, no 1's, and that would be equal to 6. Here we're taking a look at some larger binary numbers, and let's see if we can figure out what those numbers are. I've put the columns along the top, although you don't need to, just the same as you might not do in normal numbers. So this first number, 10100, it is a 16 and a 4. So 16 and 4, that number is 20. The second number, we have a 32 plus an 8, that's 40, plus the 1 at the end, that is equal to 41. This number, we have a 64 plus an 8, 64 plus 8 is 72, plus a 4, 72 plus 4 equals 76. 6. And here's an example of a question that you might be asked in an exam. Write the number 11 as a binary number. So again, I've put the column headings just to help us with this. So if we're writing the number 11, 32 is too big. 16 is also too big, but we can use an 8. So that would be our first one. That is 8. Now, if we added a 4, that would make 12. So we can't add a 4. There's a 0 there. We can add a 2. 8 plus 2 would be 10. So 8 and 2. We need one more, so we need to put a 1 on the end, because 8 plus 2 plus 1 equals 11. So 1, 0, 1, 1 is the answer. I hope you found that useful. If you did, please like and of course subscribe below here, and have a look at some of my other videos. Hopefully I'll see you again. Thank you.